Okay, this is the hybrid part of section 9.1. So continuing on with verifying identities, they're going to get a little messier as we go along here. So if we're looking to verify this identity, we know that we tend to want to start on the more complicated side. I think we can all agree that these fractions make that left-hand side the more complicated side. So we're going to start on that left-hand side. Because we have two fractions and we want to combine them, we're going to need to get a common denominator. That common denominator is just going to be the product of those two denominators. So I'm going to multiply this fraction by this denominator over itself and this fraction by the other denominator over itself. Make sure you multiply by that thing over itself because that's 1. You want to make sure when you multiply by something, you're multiplying by 1 because multiplying by 1 does not change the value of the fraction. It just makes it look different. Same thing over here. We're then going to distribute this stuff out. So 1 times this is just this. 1 times this is just this. And I went ahead and just smushed those two together. I am going to distribute them out in just a second. I just chose to not do that all at one time here. Notice my use of color here that continued on. This plus came from right there. And then combining like terms, that's a minus cosine, that's a plus cosine, so those zero off, and I get this 1 plus 1 is where that 2 comes from. That's promising because we know that this right-hand side up here that we're working toward has a 2 in it, so that's a good sign. Now, foiling out the denominator, we're going to get 1 minus cosine plus cosine minus cosine squared. Those two are going to zero off. So we just get 2 over 1 minus cosine squared theta. That is a version of the Pythagorean identity of sine squared plus cosine squared equals 1. So if you do a little manipulation of that and subtract cosine squared from both sides, you get that version. So I can replace this with just sine squared. Again, notice my use of color here is very intentional. Now at this point you might feel like you're done. You might think, ooh, that looks nice and easy, nice and simple, we're probably done, but we're not. This is what we're trying to accomplish. So where in the world is a cotangent squared going to come from? Well, this sine squared in the denominator, we're going to use a reciprocal identity. Because we know 1 over sine is the same as cosecant. So 1 over sine squared is cosecant squared. The 2, of course, just along for the ride. Cosecant squared has a Pythagorean identity that says 1 plus cotangent squared is cosecant squared. So I can replace this cosecant squared with a 1 plus cotangent squared, distribute that 2, and we're done. I know that all kind of happened fast, but that's the nice thing about it being a video is that you can go back, you can rewatch it, you can pause and see what happened there. So moving on to example 9 to verify this identity. For this one, the left-hand side again is the more complicated side. Those fourth powers, you might not know what to do with those. But if you look at a fourth power as a squared squared, we can factor that as the difference of two squares. The difference of two squares factors into a minus b, a plus b. But we need to write this as something squared minus something squared. So if we rewrite a fourth power as a squared squared, we get that this is a and this is b. So this will factor into a minus b times a plus b. Now check out what happens once I factor it. I end up with this a plus b business over here that's sine squared plus cosine squared. We know that's just 1, so that's pretty sweet. So we get this parenthesis times 1. So I don't even have to write that times 1, so I'm just going to bring down that subtraction. I want it to look like this. So I'm really close. I've got a subtraction in there, so that's good. I got a cosine squared. Somehow I got to get a 1 here, and I need a 2. Let's use a Pythagorean identity that sine squared is the same as 1 minus cosine squared. So I'm going to replace that sine squared with 1 minus cosine squared. When I do, those are like terms that I can combine. That minus 1 cosine squared minus another 1 cosine squared is a minus 2 cosine squared. So there we go. There's our right-hand side. And we're done. A lot of these identities are just a matter of trying different things, utilizing all these different kind of formulas, and just kind of having a bag of tricks. And saying, okay, well, I tried this, it didn't work, let me try this, let me try this. So my job is to just kind of fill your bag of tricks so that you can see what's happening and hopefully be able to, figure these out when they come at you. All right, this one's going to be a little messy. We're going to start on that left-hand side. First thing that catches my eye is this sign of minus x. That's one of those even-odd properties from the first formula sheet that I gave you. So that's the first thing I want to address. The sign is an odd function, so that means that the sign of minus x is the same as minus sine x. So I'm going to go ahead and replace that so that all my variables are the same. So I get tangent. There's the subtraction. This minus comes from the oddness of the sine function. The fact that it's an odd function there. So that minus times that minus is going to be a positive. Now I put a little yellow star here because I'm going to work this problem two different ways. I'm going to finish on this way, but then I'm going to revisit it, come back to this and say, okay, you could have started from here and done this a different way. So from here, that negative times that negative is a positive. We can multiply by the conjugate of the denominator. The conjugate just changes that middle sign right there. And again, when we multiply by something, we want to multiply by that thing over itself so that you're multiplying by 1, because multiplying by 1 does not change the value of the fraction. It just throws some lipstick and a dress on it. Now, distributing the top and the bottom out, we're going to get tangent times 1, tangent times cosine, sine times 1, sine times cosine. And then distributing out this bottom, we're going to get 1 times 1, 1 times cosine, cosine times 1, cosine times cosine. You'll see I've got that tangent highlighted, and I'll show you why. That's because I'm going to replace it with sine over cosine. I did that because I know that tangent is sine over cosine, and multiplying by that cosine I knew was going to cancel those out and just leave me with sine. Well, now I've got a minus sign and a plus sign. Those will zero off. So this became 1 when they canceled, and then this is minus plus, which is 0. Down here, I've got the same situation of a minus and a plus, so those zero off. That gives me tangent minus sine cosine over 1 minus cosine squared x. This 1 minus cosine squared is the same as sine squared. That's one of the Pythagorean identities. So I'm going to replace that, make it a little bit nicer. All right, here's where it really kind of breaks bad. Because at this point, I'm going to change everything to sines and cosines. So I'm just going to change that tangent to a sine over cosine. In doing so, I bring in what's called a complex fraction. A complex fraction is a fraction within a fraction. In order to clean up a complex fraction, you multiply by that least common denominator of these little fractions, those inner fractions. So there's that denominator, so I multiply by that over itself. Because the complex fraction here is kind of stacked, instead of just multiplying by cosine over cosine, I made it a little more clear that it was cosine over 1 over cosine over 1, so that it was a little easier to distribute out. Again, notice my use of color here, because that orange is important in this next step. Distributing that cosine times the top and the bottom, those cosines will cancel. So I end up with sine x minus sine times cosine squared, and then sine squared cosine. It looks like a hot mess for now, but it's about to get better. I'm going to factor out a sine x from the top, and that'll give me a 1 minus cosine squared x, which we know by the Pythagorean identity is sine squared. So that blue right there becomes just sine squared. Now that I've gotten rid of that subtraction, now I'm left with just a bunch of multiplication, which is awesome because now I can start canceling. Those sine squareds will cancel, and I get sine over cosine, which is just tangent, which way back when we started was the right-hand side of this problem. Now, as promised, I told you I was going to rework this a different way. So if you go back to the step where I put that little yellow asterisk right there, if you choose to not use the conjugate, you could have gone ahead and changed that tangent to a sine over cosine, and then simplified that complex fraction. So this is avoiding multiplying by that conjugate over itself. In doing that, when I distribute that cosine, it looks like this. Again, notice my use of color. It is very intentional here. Those cosines cancel, and I get sine plus sine cosine over cosine times 1 plus cosine x. I did not multiply this out on purpose. You're about to see why. If I factor a sine x from the top, I get sine x and then 1 plus cosine x. Those 1 plus cosine x's cancel, leaving me with sine over cosine, which is just tangent. So this is just an alternate way to do example 10. A lot of times with these more complex identities, there are various ways of doing these. So don't get discouraged if you do this differently than I do, but you still end up in the right place. It is certainly possible for that to happen. Now, though, with that said, it is possible to end up with a correct answer, but not have done it correctly. So here's our last example. A student verifies this identity in the following way. So is the student right or wrong? So they start on the left-hand side, and they split it up into sine squared over sine minus cosine squared over cosine. Cancel one of those sines with that one, cancel one of those cosines with that one, boom, sine minus cosine. This is an example of a blind squirrel finding a nut. Just kind of luck, just dumb luck. You just happen to end up at the right answer, and it's not mathematically correct. It's garbage. You cannot split up a denominator like that, okay? Instead, what you'd want to do is take this numerator and factor that as the difference of two squares. Remember this a minus ba plus b from a couple examples ago? And then sine plus cosines will cancel as one quantity, leaving me with just sine minus cosine, which is the right-hand side. So you want to be careful, because while there is different ways of doing some of these that can get you to the same correct answer, there sometimes is hot garbage that you can do that'll get you to the right answer as well. So you want to be really careful. All right, so that does conclude the hybrid part of section 9.1.